academically viable, if you will.
But it would be awesome.
So graphing and solving quadratic inequalities. Basically, you're doing the same stuff as we were earlier. Did they not know that today was happening?
What were you guys saying? That's terrible. I'm sorry. I figured that out. What? Okay, you know who I was thinking about too.
Anywho, so what we're going to do here, guys, is we're going to graph and shade inequalities with quadratics. So we're going to graph quadratics and shade them.
I can't.
We graph this the exact same way as we graphed other stuff. We don't really need to use a graphing paper.
I know.
I'm going to show you some easy ways to plot these things by hand by using a little bit of space. Because what I'm hoping that you guys are going to be able to pick up on is how do you identify your vertex, your axis of symmetry, what direction things are going, and utilize that symmetry to plot points on a parabola. Because if you do that, it's so fast, so efficient of graphing. Okay? So we have y is greater than x squared minus 2x minus 3. Remember, when we graphed this stuff about a week or so or whatever ago, what we did is we found that axis of symmetry first. How did you find that? You remember?
2 over, no, BA.
Close. Flip it.
BA over 2.
Opposite of b over 2a. Wait. Opposite b. Wait.
Yes, opposite of b over 2a. That's where it comes in the quadratic form.
So if you did one.
Negative B over 2.
That's why they make it.
2. Negative 1 over 2.
So our axis of symmetry, excuse me, we get 2 over 2. How'd you find your vertex? Doesn't the vertex lie on the axis of symmetry? So substitute in. What's 1 squared?
1.
What's 1 minus 2? Negative 1. Negative 1 minus 3. Is this up like a cup or down like a frown?
Up like a cup.
Why?
Because it's positive.
Right. So basically everything you need to know is right here.
Basically, so we don't want you to graph it. You can figure it out yourself.
What number is really, really, really close to your axis of symmetry? 0. 2 also, you're right. If I use 0, what's 0 squared?
0.
What's 0 minus 0?
0.
Minus 3.
Negative 3.
So at 0 it is negative 3. Which means at 2 it is
Negative 30.
okay. We're just starting here. Let's try and do 2 points. So let's pick another one. You want to pick 3 or do you want to pick negative 1? I would pick 3. You know why?
It's positive.
Because it's positive and you guys really aren't that good at negative numbers. No offense.
Whatever.
But
Not wrong.
I'm not wrong, it's right. 3 squared
9.
minus 6
3.
minus 3.
What do we have to put on that point?
Yeah, I want you guys to do 2 sets.
Okay.
Okay? 2 sets. Notice by using symmetric twins, it's really, really easy to do that. Okay? So now you know it's up like a cup. When I connect those, solid or dotted?
Dotted.
And why is it dotted?
Not exactly. Wow.
Because math
Can I
can't
just
be
say
that
dotted?
easy.
I wrote it as solid. Can I just write dotted? Wait.
Just like we did linear stuff, we plot this through kind of the same exact scenario, plot it through the same way. Now, we got to pick something that's not on the graph. What's not on the graph?
0.
So is 0 bigger than negative 3?
Yes.
Yeah.
Where do you think we shade?
Up.
We shade up. Now look at your curve. Is it shaded inside the curve or outside the curve then?
Inside.
Shaded inside the curve.
Doing all these last time.
That's all it is?
Why would you shade outside the curve?
Yeah, I know. I don't
What's that?
Why would you ever shade outside the curve then?
Yeah, you can shade outside because it's just true or false.
Oh, okay.
Okay, that's all it is.
So we put shade on this.
Yeah, that one. Pretty simple, huh? Okay. Let's graph an overlap. Same idea. We're going to graph the overlap of two quadratics. You do the same process, same setup, and we're going to look for your shading. So let's see. The first one is y is greater than or equal to x squared minus 9.
Minus 4, you mean?
Oh, did I say 9? Sorry. Minus 4. And the other one is y is less than negative x squared minus x plus 2. So graphing the systems, the first one has an axis of symmetry at 0. And the reason we know that is because there's no b. Correct. There's no b term, which means you're going to be at 0 for your symmetry. We also know what the y-intercept for that is. What is it? Negative 4. Okay. When you don't have that middle term, they're very, very easy to plot. Okay. So get some symmetric twins. What's 1 squared? It's 1 minus 4. So I'm here, and I'm here. What's 2 squared? I'm here, and I'm here. Very, very straightforward. Connect the dots. La 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 la. Open or dotted or solid?
Solid.
Solid as a rock. That's what feels like. Is 0 bigger than negative 4?
Yes.
Okay. Okay.
Wow.
Do the other one. The other one we do a little bit of math. So, opposite of b over 2a gives me an axis of symmetry at negative 1/2. You okay with that? I have an axis of symmetry then at negative 1/2. We'll change colors. Which gives me a vertex.
Is this the second one? How do I like do this?
1/2 squared. Well, what's 1/2 times 1/2? 1/4. What's negative 1/4 minus 1/2? Negative 3/4, and I add 2 to that, and I get 1 1/4. So it'll be at negative 1/2 and 1 1/4. It's the corn that you ate.
I thought mixed numbers didn't exist.
What?
She said.
Yeah. They don't exist, but for when I'm plotting a point, I'm not using this to do anything with it. All I'm shut. Bless you. In this case here, the reason why he's right, I don't like mixed numbers, they no longer exist, but the way that our scenario works, I'm not utilizing it to solve anything. I just said 1 1/4. That's all. This one's going to be opening downward. Why do we know that?
X is negative.
X is negative. Now, obviously, 0 is really close to our axis of symmetry.
Yep.
Okay. I don't think we did something right there.
No, I said it would be.
Is it, you have like, it's minus
Was that
x
more than
and
a
x
four?
is a negative, so it would be plus 1.
Yeah, that wasn't supposed to happen.
No, because
Yeah, I was waiting
for the symmetry here,
Yeah, it would be plus 1
opposite of B. Oh, yep, you're right. Sorry. So sorry, it's on the other side.
Yeah, you should be sorry.
My bad.
Well, now you
Now I done goofed.
done goofed everyone.
I done goofed.
I don't.
My bad. B here is negative, so it's 1 over.
Yeah, but then it's 2 negative 1, so
No,
you were right.
like,
It'd be
after
negative
that, that
1
was
over 2.
fine. When you were solving
Oh my
for
lord,
where it
that
was
is
on the
negative
y,
When you
so that's
substitute
minus.
Yeah.
negative 1
That was
half
fine.
back
It was-
Yeah, it's back
put it
over
back
there.
in.
Come on.
You know what? Today's Tuesday.
Wednesday. It's Wednesday.
See what I'm saying? All right. So we have, it's the negative 1/4 minus the negative. Yes, I see what you're
Where did
saying.
you
You're
get
right.
negative 1?
So the vertex is at 2 1/4.
Where did What?
we get negative
What?
1/4.
I'm so confused. Yeah, can you explain this, please? I don't know where you're getting the 1 from.
Once again, 1/2 squared is
Okay.
1/4. This is 1/2 times
We're
1/2.
squaring it?
Take the x value, substitute in to get the y value.
Oh, you're writing out the whole thing. Okay, now I can.
Subtract that, the negative 1/2. That's where I messed up. I forgot to put the sign back in there. Negative 1/4 minus a negative 1/2 is, so it winds up being 1/4. Add that to 2. It is now at 2 1/4. Now it makes sense why I had an axis of symmetry of my vertex here. It would be at, the next one we've gone through at 2. If I go through with it at 2, that means at negative 1 it's also right there. If I use 1, I get negative 1 minus 1 plus 2. Hopefully I do this right. 0.
Yeah.
Okay.
You got
What
it.
points
Woo.
did you use?
What points did I use? I used 0
Okay.
because it's half away from negative half. So that gives me my y-intercept, which means at negative 1 it is also 0. So then when I use 1, it goes down the other way.
Okay.
Now, this one is going to be dotted. So they overlap one another. Did that go through the origin?
No.
No. So is 0 smaller than 2?
Yeah.
Yeah. So we wind up with this overlap in here.
Sweet.
All the pretty shapes and colors and shades. You know, I would check my email for you guys to tell you what time the class is over. So we'll just wing it on one of the, whatever. Maybe it might be the next bell. It might not be the next bell. I don't know.
You see people
Guess we'll find out.
Yeah, when you see people running, we'll all leave.
Okay.
It should be at like 9:55, I think.
Dang it.
Because I remember telling my wife, hey, I get to have lunch at 10 o'clock in the morning today.
That's what I always do.
As opposed to like 10:15. It's like, oh, I'm really hungry at 3 o'clock and I want to.
I feel like and then I go to practice.
Yeah, we have coffee.
You got drill sergeant
Alright.
Actually, that's why I said
They're a little bit different now.
I think that last one was long.
We're going to solve the quadratic with one variable, which basically is asking you, where is the graph below 0? For what values of x
no part of average.
will you
is
get
zero.
below 0?
So do we do what we did yesterday, basically? Is that a good
Now,
question?
what I want you to think is when it was solving a quadratic when it equaled 0, you guys had all those different methods to do that.
Yeah.
You would factor, complete the square, quadratic formula, any of those. When it's less than or greater than, you do the same stuff.
Sweet.
What's going to be the easiest way to do this one?
Complete square.
Factoring. So what's 5? You add together, you get negative 6. Negative 5, negative 1. You can do complete the square, it just takes longer. It's the idea of being able to pick up on what's going to be the fastest.
That's the thing. I struggle.
Okay? Solve it out. Well, that means x minus 5 is less than 0. X minus 1 is less than 0. So x has to be less than 5, and x has to be less than 1. So that means when you put it all together, for all the values that are going to make this a true statement, your values of x are going to be within 5 and 1. Put this on there now. Because this curve, if you graphed it, axis symmetry is at what? 3? Because we have zeros at 5 and 1. Okay. If you think about it, it's up like a cup, so we know that it's going to do this. When is this graph below 0? When you're between 5 and 1. That's what that means. Okay?
That's
This This isn't the way to write that though. Did I flip that sign for some silly reason? We didn't teach this section. We haven't taught this section in about 3 years, to be honest with you. It's been a
Why are
while.
we teaching it again?
Why not? I don't know. Oh yeah, because I want you guys to think about it the way that this looks. Can it be written out
I know.
with this?
I really don't understand.
It has to be bigger because you have to think about what the graph is doing.
So what's the answer?
It's bigger than 1, but smaller than 5. Think about what it looks like. Okay?
I don't like this.
What you're doing here,
Why does
you
science
treat it the
switch?
same way to figure out your zeros. Okay? Treat it the same way as you figure out your zeros. Put it on the graph. And then is it going to be up or down? That's really all you're looking at. Okay? And the reason that it's up is because A is positive. So that means that it dipped below to reach those zeros. Okay? How's what? What happened was, I was setting it up to just solve your zeros like we were normally. But then when you plot it, does that make sense when you graph that? Because the parabola, because this is going to look weird because you have this in it. What it's asking you is, this is what that means. Where is it below 0? You can set up and get your zeros like you would normally, but then you have to make sure that these signs make sense to what it is. Because when we get going here, if I just give you zeros of 4 and -5, if I give you zeros of 4 and -5, that means it crosses the x-axis at 4 and -5. From there, you still don't know what direction it's going. It could be going up, it could be going down. You don't know. That's why that A value, if A is positive, that means that it's got to do this. Okay? It's going to give you a parameter. Now, even if A is negative, wouldn't it still do that? So wouldn't that be your boundaries no matter what, if you have 2 zeros? That's kind of the idea. If it's asking you for greater than or less than, it's just a matter of it's your boundary. It's your boundary. Yes, ma'am. Probably, yeah. Because if you have 2 zeros, it's going to be buffer between the two. So you have to know which one's bigger than the other. That's all. Yes, ma'am.
But like, why can you just switch the sign? You can't change like an 8 to a 2.
Well, no. What's happening here is, you go back and you just think of that, the regular zeros. You had zeros at 5 and 1. It was just asking you, where is this whole x squared minus 6x plus 5, where is this graph below 0? Well, it's below 0 when you graph it between these values. Any value of greater than 1 but smaller than 5 will give you an answer that's true. When I was doing there, and I shouldn't have done it that way, because I honestly didn't think you guys would have cared if I just wrote it out and then showed you why does it have to be a boundary. All I was doing was relaying this part to solving it as a 0. You solve it the same way if it was like that. I was just writing it out that way, that's all. It was just, I thought in my mind it would be easy for you guys to understand that all I'm doing is getting the zeros, and it's just keeping the sign just by treating it like it was an equal sign. That's all I was doing. I didn't realize it was going to be that confusing. That's all. I just assumed it wouldn't be a big deal, but I made an assumption that was wrong. So I made an angle side out of myself. See you guys again. Do you need the X? Let's try another one. Try another one. Same idea. Same exact idea here. This is asking you, where is it greater than or equal to 0? So it's asking you to basically solve for your zeros like you would normally, and then write out that as a boundary. That's all it is. Yes, ma'am.
You have to graph it, right?
Do you really? Let me show you. Let me show you what happens.
Well,
You're right, and that's where I'm getting. You don't really need the graph. I was showing it to show you what is it doing. -6 to get you 3. Anything? And then that means, well, I could complete the square, but then I'd have to deal with fractions, wouldn't I?
Yeah.
Does that factor up to 2? So which one's going to be even quicker? Quadratic formula. So the idea here is when we start to figure out where your zeros are going to be located, factoring is always real fast if you're good at multiplying. Completing the square is going to be great when you have your bless you, when you don't have a leading term coefficient or you want to know fractions. And then quadratic formula is the fallback. Yeah.
On the test, are you gonna have us like say?
Yeah, I'll say for a problem, I'll say complete the square. For something else, I'll say do this. But then I'll say solve by any means.
All right.
Okay. Alicia, what were you gonna say?
Nothing.
So opposite of B, plus or minus. Okay. Fill in the blanks. All right, I just filled in the blanks. I squared 9 real quick because that wasn't terrible. So let's see here. We get 9 plus 24. Hi. I got kicked out of the Google again.
Did you figure it out?
No, I haven't. I haven't had a chance to. What do I have to do?
I write down the special password.
Do I have to like log out of the computer and log back in?
I think so.
Well, that's going to be really annoying if I have to do that all day. Shoot.
I don't know if you have to keep doing it. Could I borrow a pencil? I think I know the special password.
All right. So what was it? Is it 33 in there? Yeah. Okay. So you wind up with these funky roots. Now here's what you have to be able to do.
How do you get 33?
Obviously what happens
I
is...
turned it upside down so no one would see.
All right.
Isn't it nice? I'm like really old and I had to help him with tech issues.
9 plus 24.
Because the Google doesn't like you.
But everybody likes me.
That's true. So here's what happens.
The face.
Somewhere this graph is crossing the x-axis. At -3 plus root 33 over 4 and at -3 minus root 33 over 4.
What?
Your goal is to figure out which of those two is greater than the other. So you have to math. Okay?
Math it out. The negative's gonna be big.
I quit this class. I'm dropping it. Let's do it. I'm moving it. I already tried. No.
Well, we know.
You add.
Well, yeah. I know. I just.
And that's all divided by 4.
You're gonna get some funky decimal, right?
How do I do this? Thanks for Which one are we supposed to see? Like, which one's like less than or like bigger? Like,
I'm too scared to take
what
the test.
equation? Like, or just just change the sign for each of them?
Well, I'll show you.
All right.
You have two values. You have two values. You have -3 plus the square root of 33. Hit enter. Divide that by 4. Hit enter. You get some decimal. Obviously, you can do the alpha y equals and do this all in a fraction bar as well. This thing is all sorts of screwed up, and I just haven't had time to get it fixed. I do the same thing. -3 minus the square root of 33. Hit enter. Divided by 4, and I get a negative. So in this case, when I subtracted it, it wound up being the smaller value than the one that was positive. So therefore, when I write out my inequality here, it was 0.6 something and then -2. We know it's doing this. So in my mind, I'm asking, where is it going to be bigger than 0? Well, any value on the outside here, then, isn't it?
Yeah.
For this to be greater than 0, that means for any number that's going this way, you're going to be greater than 0. Any number going this way, you're greater than 0.
Can you go back to the top of everything?
Because it's over the x-axis.
Oh.
Okay?
Makes sense.
What that's asking you is, where is it above the x-axis? So the idea that you don't need a perfect graph to see this is fine. What I'm looking that you guys notice is that you still get these zeros. We get a 0 here, in here. One of the zeros is at -3. Will you please just stop saying I'm so confused? It's, okay?
It's not what I said.
Yeah, you say a lot though. That value is here, okay? The other one is here. Okay? For this graph to be greater than 0, it has to be numbers that are bigger than or equal to. And the reason I put bigger or equal, because it had that. Okay? So as numbers are getting larger than this, whatever, what was it, 0.68?
Yeah.
So as soon as it's 0.69, it's going to be above 0. Okay? As soon as it's smaller than this, it's above 0.
I got it.
Because these are the zeros. Where is it bigger? As it's getting larger or it's getting smaller. So the whole idea here is why I'm plotting this as a kind of a rough idea of a graph. It's just to get that idea of where is it going. Okay? So x has to be smaller than or equal to that. Because numbers going this way are smaller than it. What's up?
So we just leave it as the -3 plus or minus square root 3 over 4. That's just the point.
Yeah, yeah. Because those are your two boundary points. Okay? The reason I had to split these things apart was because it's a compound. Okay? Compound inequalities, you're going to have stuff in between, or you're going to have stuff on the outs. All right? Depending upon how it plays about. The idea of throwing a rough sketch of a graph isn't needed, but it is helpful to see what's going on. Let me get another one of these here. We got another one. All right. Oh, that's the wrong one. Same idea. 2x squared minus 7x plus 3. Greater than or equal to 0. I'm asking, where will this graph be greater than or equal to 0? Where is it above the y-axis? Okay. We got like 2 minutes. So. This one isn't bad to factor because you've got a +6 to get you a -7. -6, -1. You know what? Let's just do this. We'll finish this one
X
tomorrow.
minus 1.
Do these. What I'd like you to do,
29 through 34.
yeah, let's just do those 6 systems. We'll worry about the solving parts with the other funkiness later. So this is on 304. I figured why give you both doing the single ones? Might as well do a system because you're just doing those. Let's just go up to 33. That we don't need to do that many of them. All right. So this is on 5, 7. What was it? 304.
Yeah.
Yep.
Do those 5 of them. 29 to 33. We'll keep going on to the other one. It's a little bit more than I hoped to get through today. Oh well.
No.